Hello, in this video I'm going to be introducing you to histograms. Now these are sort of like bar charts, except the area of each bar is going to be giving us a frequency. Now the reason these are so useful is because they allow us to see the distribution of our data a lot more clearly. Okay, so we'll start off by looking at how to sort of construct a histogram, and then we're going to answer a few questions using it. And I'll timestamp each of the parts of the video below so you can skip through to whichever part you want to see. And if this video is useful, please do like and subscribe. To see why our histograms are useful, let's take a look at this example here then. So we've been given a table which shows us the different times people take to get to work. And so you can see 30 people take between 0 and 10 minutes, and so on for the rest of the data. So I'm going to use this data to create a bar chart. So my first bar is going to represent the number of people that take between 0 and 10 minutes to get to work. So it's going to look something like this. My second bar is going to be the number of people that take between 10 and 15 minutes to get to work. So it's going to look like this. And my final bar is going to be the number of people that take between 15 and 20 minutes to get to work. Now, initially, right, say we look at this bar chart. It could be argued it is a little misleading because the first class has the greatest frequency, which is true, it does. But the reason its frequency is so large is probably because it has the largest class width. Because look, if I add a new column for the class width, well, the first row has a class width of 10, and then my second bar has a class width of 5, and so does my third. And so you could say, well, the class width of the first bar is double that of the other two, so there's a broader range of data we have there, so it probably makes sense that it has the largest frequency, and it can kind of make it harder for us to see the shape of the distribution. And so to fix this, what we could do is create a histogram. Now with a histogram, we change the vertical axis from being the frequency to being what we call the frequency density. Okay, and the formula for that is this. It's the frequency density is just our frequency divided by our class width. And so what I'm going to do is use the exact same data, but this time create a histogram from it. So let's take a look at how we do that. I've added a new column for my frequency density. And so to calculate that, I do the frequency, so for the first row it's 30, divided by the class width, which is 10. And so I get a frequency density of 3. For the second row, I take my frequency of 20 and divide it by the class width of 5, and we get 4. And for the final row, we're going to do 25 divided by 5, which is 5. So now we've calculated the frequency densities. Let's put this onto our histogram, and I'm just going to move this out of the way slightly. So I'm going to have for my values between 0 and 10 minutes, so my first bar is going to go from 0 to 10 minutes, and it's going to have a frequency density of 3, so it's going to look like this. My second bar is going to go from 10 to 15 minutes and have a frequency density of 4, so it's going to look like this. Now notice my bars are touching each other, and that's because this is continuous data, and so I don't want there to be any gaps in it. Okay, it's just going to go from one straight to the other. My final bar is from 15 to 20 minutes, and it's got a frequency density of 5. And so now you can see we've created this histogram, and we can clearly see the shape of the distribution a lot easier. Okay. Now you don't just need to be able to create a histogram like this, you also need to be able to interpret it. So here are some questions we have. So the first one, we have to estimate the number of people who took between 0 and 5 minutes to get to work. Now, very importantly, notice this is just an estimate because we don't have the data, so we can't get an exact value. But the way we're going to estimate this is by looking at the area, okay, between 0 and 5 minutes of our bar. So this shaded area here, that's going to tell us an estimate for the number of people who took between 0 and 5 minutes to get to work. And remember, if you're unsure, we could actually use our formula that we've got here and rearrange it to find the frequency. So that's the frequency density, which in this case is 3 for this bar. So let me write that down. It's 3. And it would be multiplied by the class width, which is 5. And so we get an estimate of the frequency of people, which is 15. Okay, let me remove this now just in case I need to use my histogram again. So the second one wants us to estimate the number of people who took over 10 minutes to get to work. So over 10 minutes, okay, well that's going to be anyone who is past this point on my histogram. So that's the area of this bar here plus the area of this bar here. Okay, hopefully you can see that. So let's find the area of the first bar. Well, it's got a class width of 5, okay, and I'm multiplying that by the frequency density, which is 4. So I'm just doing 5 multiplied by 4, which is 20. so that's for the first bar, plus the area of the second bar, which is again 5, but this time multiplied by the frequency density, which is 5. So it's just 5 multiplied by 5, which is 25. So 20 plus 25 equals 45. There we go. And finally, we need to estimate the probability a randomly chosen person takes between 5 to 10 minutes to get to work. Okay, so let's have a look. So between 5 and 10 minutes. So let's find the number of people, or estimate the number of people that took between 5 and 10 minutes. So that's going to be anyone in this area of our histogram. So we need to calculate this area here. So that's 5 multiplied by 3. So 5 multiplied by 3 is 15. So an estimate of 15 people took between 5 to 10 minutes to get to work. So the probability that one is chosen at random, well, we take that 15 and divide it by our total frequency. So we could calculate the total area of all the bars, or we could just take a look at our table up here and calculate the total frequency, which is 30 plus 20 is 50, plus 25 is 75. So the probability is 15 out of 75. And let's simplify that to 1/5. So that's it for this video. Hopefully it was useful. If it was, please do like and subscribe, and go over to my channel where I have loads of other maths tutorials. Thanks for watching.